let's learn the Rust programming language. Okay. Forward wasn't always clear, but Rust programming language is fundamentally about empowering. No matter what kind of code you are writing now, Rust empowers you. I'm not gonna read this introduction. Okay. Yeah. This edition of the book is the same as the Rust programming language, available in print and ebook format from No Scratch Press. Welcome to the Rust programming language, an introductory book about Rust. The Rust programming language helps you write faster, more reliable software. High-level ergonomics and low-level control are often at odds in programming language design. Rust challenges that conflict through balancing powerful technical capacity and great developer experience. Rust gives you the option to control low-level details such as memory usage without all the hassle traditionally associated with such control. Who is Rustful? Rust is ideal for many people for a variety of reasons. Let's look at the few most important groups. Team of developers. Rust is proving to be a productive tool for collaborating among large teams of developers with varying levels of system programming knowledge. Low-level code is prone to a variety of subtle bugs, which in most other languages can be caught only through extensive testing and careful code review by experienced developers. In Rust, the compiler plays a gatekeeper role by refusing to compile code with these elusive bugs, including concurrency bugs. By working alongside the compiler, the team can spend their time focusing on the program's logic rather than chasing down bugs. Rust also brings contemporary developer tools to the systems programming world. Cargo, the included dependency manager. Also, it's okay. Cargo, the included dependency manager and build tool, makes adding, compiling, and managing dependencies painless and consistent across the Rust ecosystem. Rust format ensures a consistent coding style across developers. The Rust language servers powers integrated development environment integration for code completion and inline error messages. By using these and other tools in the Rust ecosystem, developers can be productive while writing system-level code. Students. Rust is for students and those who are interested in learning about systems concept. Using Rust, many people have learned about topics like operating systems development. The community is very welcoming and happy to answer student questions. Through efforts such as this book, Rust teams want to make systems concept more accessible to more people, especially those new to programming. Companies, hundreds of companies, large and small, use Rust in production for a variety of tasks. Those tasks include command line tools, web services, DevOps tooling, embedded devices, audio and video analysis and transcoding, cryptocurrencies, bioinformatics, search engines, Internet of Things, applications, machine learning, and even major parts of the Firefox web browser. Open source developer. Rust is for people who want to build the Rust programming language community. Developers, tools, and libraries. We'd love to have you contributed to the Rust language? People who value speed and stability. Rust is for people who crave speed and stability in a language. By speed, we mean the speed of the programs that you can create with Rust, and the speed at which Rust lets you write them. The Rust compilers checks ensure stability through feature addition and refactoring. This is in contrast to the brittle legacy code in languages without these checks, which developers are often afraid to modify. By striving for zero cost abstractions, higher level features that compile to lower level code as fast as code written manually, Rust endeavors to make safe code be fast code as well. The Rust language hopes to support many other users as well. Those mentioned here are merely some of the biggest stakeholders. Overall, Rust's greatest ambition is to eliminate the trade-offs that programmers have accepted for decades by providing safety and productivity, speed and ergonomics. Give Rust a try and see if its choices work for you. Who this book is for? This book assumes that you've written code in another programming language, but doesn't make any assumptions about which one. We've tried to make the material broadly accessible to those from a wide variety of programming backgrounds. We don't spend a lot of time talking about what programming is or how to think about it. If you're entirely new to programming, you would better served be you would be better served by reading a book that specifically provides an introduction to programming. How to use this book. In general, this book assumes that you're reading it in sequence from front to back. Later chapters build on concepts in earlier chapters, and earlier chapters might not delve into detail on a topic. We typically revisit the topic in a later chapter. You'll find two kinds of chapters in this book: concept chapters and project chapters. In concept chapters, you will learn about an aspect of Rust. In project chapters, we'll build small programs together, applying what we've learned so far. Chapters 2, 12, and 20 are project chapters. The rest are concept chapters. Chapter 1 explains how to install Rust, how to write a Hello World program, and how to use Cargo, Rust's package manager, and build tool. Chapter 2 is a hands-on introduction to the Rust language. Here we cover concepts at a high level, and later chapters will provide additional detail. If you want to get your hands dirty right away, chapter 2 is the place for that. At first, you might even want to skip chapter 3, which covers Rust features similar to those of other programming languages, and head straight to chapter 4 to learn about Rust ownership. However, if you are a particularly meticulous learner who prefers to learn every detail before moving on to the next, you might want to skip chapter 2 and go straight to chapter 3, returning to chapter 2 when you'd like to work on a project applying the details you've learned. Chapter 5 discusses structs and methods. Chapter 6 covers enums, match expressions, and the flet control flow struct. You'll use structs and enums to make custom types in Rust. In Chapter 7, you'll learn about Rust's module system and about privacy rules for organizing code and its public application programming interface. Chapter 8 discusses some common collection data structures that the standard library provides, such as vectors, strings, and hash maps. Chapter 9 explores Rust's error handling philosophy and techniques. Chapter 10 digs into generics, traits, and lifetimes, which give you the power to define code that applies to multiple types. Chapter 11 is all about testing, which, even with Rust safety guarantees, is necessary to ensure your program's logic is correct. Chapter 12, we'll build our own implementation of a subset functionality of the grep command line tool that searches for text within files. For this, we'll use many concepts we discussed in the previous chapters. Chapter 13 explores closures and iterators. Features of Rust that come from functional programming languages. Chapter 14, we'll examine cargo in more depth and talk about best practices for sharing your libraries with others. Chapter 15 discusses smart pointers that the standard library provides and the traits that enable their functionality. Chapter 16, we'll walk through different models of concurrent programming and talk about how Rust helps you program in multiple threads fearlessly. Chapter 17 looks at how Rust idioms compare to object-oriented programming principles that you might be familiar with. Chapter 18 is a reference on patterns and pattern matching, which are powerful ways of expressing ideas throughout Rust programs. Chapter 19 contains a smorgasbord of advanced topics of interest. Smorgasbord is like a collection. Smorgasbord. How's smorgasbord? Smorgasbord. Okay. Buffet. Yeah. Of advanced topics of interest, including unsafe Rust, macros, and more about lifetimes, traits, types, functions, and closures. Chapter 20 will complete a project in which we'll implement a low-level multi-threaded web server. Finally, some appendices contain useful information about the language in a more reference-like format. Appendix A covers Rust keywords. Appendix B covers Rust operators and symbols. Appendix C covers derivable traits provided by the standard library. Appendix D covers some useful development tools. Appendix E explains Rust editions. There's no wrong way to read this book. If you want to skip ahead, go for it. You might have to jump back to earlier chapters if you experience confusion, but do whatever works for you. An important part of the process of learning Rust is learning how to read the error messages the compiler displays. These will guide you toward working code. As such, we'll provide many examples that do not compile along with the error messages. With the error message, the compiler will show you in each situation. Know that if you enter and run a random example, it might not compile. Make sure to read the surrounding text to see whether the example you are trying to run is meant to error. Ferris will also help you distinguish code that isn't meant to work. Ferris, okay, on the question mark. This code does not compile. This code panics. This code block contains unsafe code. This code does not produce the desired behavior. Okay, in most situations, we'll lead you to the correct version of any code that doesn't compile. Source code. The source code from which this book is generated can be found on GitHub. Okay, getting started. Let's start your journey. Okay, installing Rust. I've already done that. Writing program prints hello world. Using cargo Rust. Okay. Installation. I've done that already. Yeah. Okay, yeah, I'm using the nightly. You should see the version number. Okay. If you see information, you have installed Rust successfully, local documentation. Yeah, I don't need Rust up doc. Okay. Hello world. Now that you've installed Rust, let's write your first Rust program. It's traditional learning. Yeah. This book is based familiarity with command line. Okay. You don't need this. Creating a project directory. You'll start by making a directory to store your Rust code. It doesn't matter to Rust where your code lives, but for the exercise with the book, we suggest making a projects directory in your home directory and keeping all your projects there. Okay. Can make it like Rust projects. Oh, come on. Okay. Okay, open a terminal and enter the following commands to make projects directories. Sure. Writing and okay. Next, make a source code, always end with rs extension. If you're using more than one word, use an underscore to separate them. For example, use hello world. Okay. File name main.rs. Okay. Main.rs. Okay. If in main print len hello world. Come on. Okay. Save the file, go back to terminal rust c main rs. Okay. Main hello world. Okay. The guards of your operating system hello world should print. Okay. If hello world, okay. Anatomy of a Rust program. Let's review in detail. Okay. What happened? Here's the first piece, function main. These lines define a function in Rust. The main function is special. It is always the first code that runs in every executable Rust program. The first line declares a function named main that has no parameters and runs nothing. If there were parameters, they would go inside the parentheses. Also note that the function body is wrapped in curly braces. Rust requires these all around all function bodies. It's good style to place the opening curly bracket on the same line as the function declaration, adding one space in between. Adding one space in between. So it's not... Okay. At the time of this writing, an automatic formatter tool called Rust Format is under development. If you want to stick to a standard style across Rust projects, Rust Format will format your code in a particular style. Let's see. Rust. Okay. The Rust team plans to eventually include this tool with the standard Rust distribution like Rust-C. So depending on when you read this book, it might already be installed on your computer. Check with the documentation. Okay. Inside the main function, this is the following code. Print. This line does all the work in the little program. It prints text to the string. There are four important details to notice here. First, Rust style is to indent with 4 spaces, not a tab. Okay. Second, print line exclamation point calls a Rust macro. If it called a function instead, it would be entered as println without the exclamation point. We'll discuss Rust macros in more detail in chapter 19. For now, you will need to know that using a exclamation point means that you're calling a macro instead of a normal function. Third, you see the hello world string passed. We pass the string as an argument to println, and the string is printed to the screen. Okay, fourth, end the line with a semicolon, which indicates this expression is over and the next one is ready to begin. Most lines of Rust code end with a semicolon. Okay. Compiling and running are separate steps. You've just run newly created. Let's examine the each step. Okay, Rust-C. Before running the program, you must compile Rust-C command. Okay. You'll notice that it's similar to GCC or CLang after compiling successfully. Rust. Sure. On Linux, PowerShell, you can see the executable. Yeah, sure. Source code. Okay, but if you're familiar with dynamic language like Ruby, Python, JavaScript, you might not be used to compiling and running program-specific steps. Rust is ahead of time compiled language, meaning you can compile a program and give the executable to someone else, and they can run it even without having Rust installed. If you give them the rb.py.js file, they need to have Ruby, Python, JavaScript implementation installed respectively. But those languages you need, okay, sure. Rust compiling Rust-C is fine for simple programs, but your project grows, you will want to manage all the options and make it easy to share code. Next, we'll introduce the cargo tool, which will help you. Okay. Hello, cargo. Cargo is Rust-built system. Most Rust stations use this tool to manage their projects. Actually, okay. In seamless Rust programs like this one we've written so far, we don't have dependencies. If we, okay. Because the vast majority of Rust programs use cargo, the rest of this book assumes that you're using cargo too. Cargo comes installed with Rust. If you, okay. Creating, okay, cargo new, hello world. Okay. The first command creates a new directory called hello cargo. We've named our project hello cargo. Cargo creates, okay, they go into hello cargo command and list the files. You will see that just a moment. Okay. Going to the hello cargo. It is also initialized. Get repository, get ignore. Okay. Cargo source directory with main RS. Okay. Cargo new. Get files won't be generated if you run cargo new within get common. Okay, sure. Open cargo. I need to do something. Just a moment. How do I? Yeah, paper. With the screen capture. Just a moment. Mm, Okay. Sorry for this um the interruption. Let's continue. Open cargo Tomo and in your text editor of choice, and it should look some similar to the code in listing 1.2. Okay. Name, version, author, edition. This file is in the Tom's obvious minimal language format, which Cargo's configuration format. The first line, package, is a section heading that indicates the following statements configuring a package. And as we add more information to this file, we'll add other sections. The next four lines set the configuration information Cargo needs to compile your program, the name, version, who wrote it, and the edition of the Rust to use. Cargo gets your name and email information from your environment, so that information is not, if that information is not correct, fix the information now. And then save the file. We'll talk about the edition key. Okay. The last line, appendices, is the start section of the for you to list any of your project's dependencies. In Rust, packages of code are referred to as crates. We won't need any other crates for this project, but we will in the first project in chapter 2. We'll use this dependencies section that generated hello world program for us. Just differences between our previous project and the cargo one. Generates, we have cargo configuration and okay, temp directory. Cargo expects your source files to live inside the source directory. The top level project directory is just for readme files, license information, configuration files, and anything else not related to your code. Using cargo helps you organize project. This place, okay, there's place for everything, and everything in its place. If you start a project that doesn't use cargo, as we did in the Hello World project, you can convert it to a project that does use cargo. Move the project code into the source directory and create an appropriate cargo.toml file. Building and running a cargo project. Now let's look at the difference. Okay, cargo build. Okay, this command line. Okay, and tar get debug. Hello cargo. Okay, cargo run. Okay, if all goes okay, command line executable. Sure. If all goes well, hello world should print the terminal running cargo for the first time. Causes target cargo created in your file. Cargo.lock. This file keeps track of the exact versions of dependencies in your project. This project doesn't have dependencies, so that the files is a bit sparse. You won't ever need to change files manually. Cargo manages to its contents for you. Let's take a look. Okay. Cargo none. Notice that this time we didn't see it indicate. Okay, cargo was compiling. Cargo figured out that the file hadn't changed, so it just ran the binary. If you had modified the source code, Cargo would have built the project before running it, and you'd have seen this output: compiling, then finishing. Okay. Okay, Cargo provides cargo check command. This command quickly checks your code to make sure it compiles, but it doesn't produce an executable. Why would you not want to? Well, much faster than cargo build, because it skips this step of producing an executable. If you're continually checking your work while writing the code, use cargo check will speed up the process. As such, many Rust stations run cargo check periodically as they write their program to make sure it compiles, then run cargo build when they're ready to use the executable. Let's recap that we've learned so far. We can build using cargo, using cargo check, without producing a binary. Instead of saving the result of the binary in the same directory as our code, cargo stores it in the target build debug directory. An additional advantage of using cargo is that the commands are the same no matter which operating system you're on. Okay. Building for release. When your project is finally doing cargo build dash release to compile it with optimization. This command will create the target release instead of target debugging. Okay. The optimization will code run faster, but turning them on lengthens the time it takes for your program to compile. This is why there are two different profiles, one for development, when you want to rebuild quickly and often, and another one for building the final program and give user that want. Okay. If you're benchmarking your code's running time, be sure to run cargo release and benchmark with the executable and target release. Cargo as convention. With some projects, Cargo doesn't provide a lot of value over using Rust C, but will prove its worth as your programs become more intricate. With complex projects composed of multiple crates, it's much easier to let Cargo coordinate the build. Even though the Hello Cargo project is simple, it now uses much of the real tooling you will use in the rest of your career. In fact, to work on any existing projects, you can use the following command to check the, git clone somebody, cd into the project cargo build. Summary, sure. Okay, this is a great time to build more substantial programs. Okay, if you'd rather, sure. Next, this is chapter 2, guessing game. Just a moment. Okay. All right. Chapter 2, Programming a guessing game. Let's jump into Rust by working through hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. You learn about let match methods, associated functions, and using standard crates and more. The following chapters will explore these ideas in more details. In this chapter, you will practice the fundamentals. We'll implement a classic beginner's programming problem, a guessing game. Here's how it works. The program will generate random integer between 1 and 100. Then prompt the player enters on a guess. After the guess is entered, the program will indicate whether the guess is too low or too high. If the guess is correct, the program will print a congratulatory message and exit. Setting up a new project. To set up a new project, go to projects directory that you create in chapter 1, make a new project using cargo. So like cargo, new guessing game. The first command, cargo new, takes the name of the project guessing name as the first argument. Okay, guessing name, your name, etc. If the author information is not correct, fix that in the file and save it. Cargo new, hello world, run. We don't need that. Processing a guess. The first part in guessing a game will ask the user to process that input and check that the input is in the expected form. To start, we allow the player to input a guess. Enter code. Okay. Use stdio. Guess the number. Please input your guess. Okay. Let mutable guess equals string new io stdn dot read line and and mutable yes dot expect failed to read line. Print line. um, you guessed guess. Okay. Shift CZ and Rust format. Rust format src main and cargo build. Cargo run. Input your guess 100. You guessed 100. Okay, the code uses a lot of information, so let's go over it line by line. To obtain user input, then print the result as output, we need to bring the IO input output library into scope. The IO library comes from the standard library, which we know as std. Use std.io. By default, Rust brings only a few types into the scope of program, the prelude. If a type you want to use isn't in the prelude, you have to bring that type into scope using explicitly with a use statement. Using std.io library provides you with a number of useful features, including the ability to accept user input. As you saw in chapter 1, main function is the entry point to the program. If in syntax declares a new function, parentheses indicating no parameters, and curly brackets. Curly braces, right? Not curly bracket. Curly brace. Yeah, okay. USMK. Braces. Just right. As you also learned in chapter 1, println is a macro that inputs a string to the stream. Okay. Next, we'll create a place to store the user input like this. Let mutable guess equals string mu. Now the program is getting interesting. There's a lot going on in this little line. Notice that this is a let statement, which you use to create a variable. Here's another example. Let foo equals bar. The line creates a new variable named foo and binds it to the variable var. In Rust, variables are immutable by default. We'll be discussing this concept in detail, variables and mutability in section chapter 3. The following example shows how to use mutable before a variable. Let foo equals bar. Let mute bar equals 5, mutable. Syntax starts comment, okay. Let's return to the guessing program. You know that let mute guess will introduce a mutable variable named guess. On the other side of the sign equal is the value that guess is bound to, which is result of calling string new, a function that returns a new instance of a string. A string type provided by standard library is a growable UTF-8. This is growable, so it's not like Java strings. UTF-8 encoded bit of text. The colon colon syntax in the colon colon new lines indicates that new is an associated function of the string type. An associated function is implemented on a type, in this case string, rather than on a particular instance of a string. Some languages call this a static method. Okay. This new function creates a new empty string. You'll find a new function on many types because it is a common name for a function that makes a new value of some kind. To summarize, let mutable guess equals string new line has created mutable variable that is currently bound to a new empty instance of a string. Woo! Recall that we included the input-output functionality from the standard library use stdio on the first line of the program. Now we call the stdin function from the IO module. stdin, okay, if we hadn't put the use stdin IO at line of the program, we could have written this function as stdin stdio stdin. The std function returns an instance of stdio stdin, which is a type that represents a handle to standard input for your terminal. The next part of the code, .readLine reference mutable guess, calls the readLine method on standard input handle to get input from the user. We're also passing one argument to readLine at reference mutable guess. The job of readLine is to take whatever the user types into the standard input and place it into a string. So it takes that string as an argument. The string needs to be mutable so that method can change the string content by adding user's input. The AND indicates that this argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy the data into memory multiple times. References are a complex feature, and one of Rust's major advantages is how safe and easy it is to use references. You don't need to know a lot of these details to finish this program. For now, all you need to know that, like variable, references are immutable by default. Hence, you need to write and mute guess rather than and guess to make it mutable. Chapter 4 will explain references more thoroughly. Handling potential failure with the result type. We're still working on this line of code, although we're now discussing a third line of text. It is still part of a single logical line of code. That next part is this method. Expect failed to read line. This reminds me of Zig. Yeah. General purpose programming language tool chair for maintaining robust, optimal, reusable software. Anywho, when you call a method with a .foo syntax, it is often wise to introduce a new line and other white space to help break it up. To help break up long lines. We could have written this code as IO, yeah. However, one long line is difficult to read, so it's best to divide it. Now let's discuss this line. Then, yeah, okay. As mentioned earlier, read line puts what the user types into the string we're passing, but also returns a value. In this case, IO result. The result types are in its standard library. Oh wait, result has a number of types named result, and its Rust has a number of types named result in its standard library, a generic result, as well as specific versions for submodules such as IO results. The IO result types are the result types are enumerations, often referred to as enums. As enumeration, an enumeration is a type that can have fixed set of values. Okay. The result types are enumerations, often referred to as enums. An enumeration is a type that can have fixed set of values, and those values are called enums variant. Chapter 6 will cover enums in more details. For result, the variants are OK or error. The OK variant indicates the operation was successful, and inside the OK is the successfully generated value. The error variant means the operation failed. An error contains information about how or why the operation failed. The purpose of the result types is to encode error handling information. Values of the result type, like values of any type, have methods defined on them. An instance of IO result has an expect method that you can call. If this instance of result is an error value, expect will cause the program to crash and display the message that you passed as an argument to expect. If readLine method returns an error, it would likely be a result of error coming from the underlying operating system. If this instance of IO result is an OK value, expect will take that return value that OK is holding and return just that value to you so you can use it. In this case, that value is the number of bytes in what the user entered into standard. Yeah. If you don't call expect, the program will compile, but you'll get a warning. Warning. Unused must use on by default. This result may be an error variant. in which should be handled. Okay. Rust warns you that you haven't used the result value returned from the read line, indicating that what your program hasn't handled as that the program hasn't handled a possible error. The right way to suppress the warning is to actually write the error handling because you just want the to crash this program when the a problem occurs. You can use expect. You'll learn about recovering from errors in chapter 9. Printing values with print placeholder. Okay. Printing values with println placeholders. Aside from the closing curly bracket, there's only one more line to discuss in the code added so far, which is the following. You guessed this. This line prints the string we saved in the user input. The set of curly brackets is a placeholder. Think of as a little crab pincers hold the value entries. You can print more than one value using curly braces. The first set of curly braces holds the first value listed after the format string. The second set holds the second value, and so on. Printing multiple values in one call to println would look like this. Let x5, y10, x equals y equals xy. Yeah. Testing the first part. Sure. At this point, the first part, yeah. Generating a secret number. Next, we need to generate a secret number that the user will try to guess. The secret number should be different every time, so the game is fun and it's fun to play more than once. Let's use a random number between 1 and 100 so the game isn't too difficult. Rust doesn't yet include random number functionality in its standard library. However, the Rust team does provide a rand crate. What does it use to generate random numbers? The core random number generation trait of this Rand live in the Rand core crate, but are also exposed here. RNG implementations should prefer to use Rand core, while most other users should depend on Rand core traits. Core traits and neurotypes of the Rand library. Okay, this crate is intended for use when implementing the core trait. RNG core defines. Okay, block the core of random generate traits. Anyhow, using a crate to get more functionality. Remember that a crate is a collection of Rust source code files. The project we've been building is a binary crate, which is inexecutable. The RAND crate is a library crate, which contains code intended to be used by other programs. Cargo's use of external crates is where it really shines. Before we can write code that uses RAND, we need to modify Cargo Tomo to include the RAND crate as a dependency. Open that file now and add the following line to the bottom beneath dependency section that Cargo created for you. Okay? Okay. Struggling to type. Okay. In the cargo toml file, everything that follows the header is part of a section that continues until another section starts. The dependencies section is where you tell cargo which external crates your project depends on and which versions of those crates you require. In this case, we specify the RAND crate with the semantic version specifier 0.55. Cargo understands semantic versioning, sometimes called SymVer, which is a standard for writing version numbers. The number 0.55 is actually shorthand for caret 0.55, which means any version that has a public API compatible with version 0.55. Now, without changing any of the code, let's build the project as shown in Listic 2.2. Cargo build. Okay. You may see different version numbers, but they will all be compatible with the code, thanks to SymVer. Different lines depending on the operating system, and the lines may be in different order. Now that we have an external dependency, Cargo fetches the latest versions of everything from the registry, which is a copy of data from crates.io. Crates.io is where people in the Rust ecosystem post their open source Rust projects for others to use. After updating the registry, Cargo checks the dependencies section and downloads any crates you don't have yet. In this case, although we only listed RAND as a dependency, Cargo also grabbed libc and RAND core because RAND depends on those to work. After downloading the crates, Rust compiles them and then compiles the project with the dependencies available. If you immediately run cargo build again without making any changes, you won't get any output aside from the finished line. Cargo knows it's already downloaded and compiled the dependencies, and you haven't changed anything about them in your cargo.toml file. Cargo also knows that you haven't changed anything about your code, so it doesn't recompile that either. With nothing to do, it simply exits. If you open the source main file, make trivial changes, save it, and build again, you will only see 2 lines of output. Compiling, finished. These lines show Cargo only updated the build with your tiny change to the main file. Your dependencies haven't changed, so Cargo knows it can reuse what it has already downloaded and compiled for those. It just rebuilds your part of the code. Ensuring reproducible builds with cargo.lock file. Cargo has a mechanism that ensures you can rebuild the same artifact every time or anyone else builds your code. Every time you or anyone else builds your code. Cargo will use the only versions of dependencies you specified until indicate otherwise. For example, what happens if next week version 0.56 of the RAND crate comes out and contains an important bug fix that also contains a regression that will break your code? The answer to this problem is the cargo.log file, which was created the first time you ran cargo build and is now in your guessing game directory. When you build a project for the first time, Cargo figures out all versions of dependencies that fit the criteria and then writes them to the cargo.log file. When you build your project in the future, Cargo will see that cargo.log file exists and use version specifier rather than doing all the work of figuring out versions again. This lets you have a reproducible build automatically. In other words, your project will remain at 5.5 until you explicitly upgrade, thanks to cargo.log file. Updating a crate to get a new version. When you do want to update a crate, Cargo provides another command, update, which will ignore the cargo.log file and figure out the latest versions that fit your specifications in cargo.toml. If that works, Cargo will write those versions to the cargo.log file. But by default, Cargo will only look for versions greater than 0.55 and less than 0.6. If the RAND crate has released 2 new versions, 0.56 and 0.6, you would see the following if you ran Cargo update. Yeah, at this point, to 0.56. At this point, you would also notice a change in your cargo.log file, noting that the version of RAND create you are using is 0.56. If you wanted to use RAND version 0.6 or any version of the 0.6 X series, you have to update the cargo.toml file to look this instead. Okay. The next time you run cargo.build, Cargo will update registry of crates available and reevaluate your RAND requirements according to the new version you have specified. There's a lot more to say about Cargo and its ecosystem, which we'll discuss in chapter 14. But for now, that's all you need to know. Cargo makes it very easy to reuse libraries, so rustaceans are able to write smaller projects that are assembled from a number of packages, generating a random number. Now that you've added rand crate to toml, let's start using rand. Next step is to update the main as shown. Okay, here's the secret number. Vim source main use rand RNG. Let secret number equals rand thread RNG gen range 1 to 101 dot gen range between 1 exclusive 101 1 inclusive 101 exclusive. Okay, cargo build. Okay, first we add use line and use rand RNG. The RNG trait defines methods that random number generators implement, and that this trait must be in scope for use for those for us to use those methods. Chapter 10 will cover traits in detail. Next, we're adding two lines in the middle. The rand two lines. Oh, the secret numbers. Okay. This is what's missing. Print line. The secret number is secret number. Okay. Shift Z. Cargo build. Okay, cargo run. Section number is 1. Section number is 80. Okay. First, we add use line and rand. The rand trait defines method run that random number generator implement. Oh, we're doing this. Next, we're adding two lines in the middle. The rand thread RNG function will give us a particular random number generator that we are going to use, one that is local to the current thread of execution and seeded by the operating system. Then we call genRange method on random number generator. This method is defined by the RNG trait and that we brought into scope with the use RNG statement. The genRange method takes two numbers as arguments and generates a random number between them. It's inclusive to the lower bound and exclusive to the upper bound. So we need to specify 1 and 101 to request a number between 1 and 100. You won't know which traits to use and which methods and functions to call from a crate. Instructions for using crate are in each crate's documentation. Another neat feature of cargo is that you can run cargo doc open command, which will build documentation provided by all your dependencies locally and open it in browser. If you're interested in other functionality by the RAND crate, for example, cargo doc open, okay, okay. The second line we added to the middle code prints the secret number. This is useful while we're developing the program to be able to test it, but we'll delete it from the final version. It's not much of a game if the program prints the answer as soon as it starts. Okay, you should get different random numbers. Okay. Comparing the guess to the secret number. Now that we have, okay, let's step down. Won't compile yet. You guessed, okay. Match, guess, compare, secret number. Ordering less, print too small. Ordering greater, too big. Ordering equal. So it matches, yeah. Compare secret number. Oh, yeah. Guess is a number. Compare at secret number. I think it's not gonna compile because this is a string and this is a number, right? Right? Okay. The first new bit here is another use statement. Use compare cd compare ordering. Cd compare into the scope from the standard library. Like result, ordering is another enum, but the variants for ordering are less, greater, and equal. These are three outcomes that are possible when you compare two values. Then we add 5 new lines at the bottom that use the ordering type. The compare method compares two values and can be called on anything that can be compared. It takes a reference to whatever you want to compare. Here it's comparing the guess to secret number. Then it returns a variant of ordering enum. Use a match expression to decide what to do next based on which variant of ordering. Okay. So match, okay. And Rust takes the values given to match and looks through each arm pattern in turn. The match construct and patterns are powerful features in Rust that lets you express a variety of situations your code might encounter and make sure that you handle them all. These features will be covered in detail in chapter 6 and 18 respectively. Let's walk through an example of what would happen with the match expression used here. Say that the user has guessed 50 and the randomly generated secret number is this time is 38. 50, 38. When the code compares 50 to 38, the compare method will return ordering greater because 50 is greater than 32. The match expression gets the ordering greater and value and starts checking each arms pattern. It looks first arm pattern is less and sees the value or does not match less, and okay, does match. The associated code that this arm will print too big. The match expression ends because it has no need to look at the last arm in this scenario. Okay, so it's not like switch statement that will continue to run. Yeah. Yeah, expected struct string. Yeah, found integer. Yeah, working to yeah. For more information, the core of the error is that there are mismatched types. Rust has strong static type system. However, it has also type inference. When we wrote let mutable guess equals string new, Rust was able to infer that guess should be a string and didn't make us write the type. The secret number, on the other hand, is a number type. A few number types can have a value between 1 and a few number types can have value between 1 and 100. I32, a 32-bit number. U32 is unsigned 32, and I64 as well as others. Rust defaults to I32, which is the type secret number, unless you add type information elsewhere that could cause Rust to infer a different numerical type. The reason for the error in Rust that cannot compare string and a number type. Ultimately, we want to convert a string the program reads as input into the number type so that we can compare numerically to the secret number. We can do so by adding another line to the main function. Okay. Guess let guess the trim dot parse dot expect please type a number. You guessed guess. Let's try to do so. Use std ordering. What was the std comp ordering? Okay. Secret number, please enter guess. Fail to read line. Let guess. This is shadowing, I guess. Guess dot trim first, parse second, expect please enter a number. Okay. Now here's match. Guess dot compare. Compare secret number ordering greater than ordering greater then too big, too small, and there's still